Okay, this is question 4, and this is a great one on questioning on whether the aircraft will make the runway. And if I can find it, I'll actually attach a video on an actual disaster that happened in flight for a jet airliner, which had this exact scenario happen. It had an engine failure, and they had to calculate whether they would make, and they had total systems failures basically, and ended up landing on an old World War II airstrip where people were picnicking and people had to run and hide. And I think the pilot actually was a glider pilot as well. And they actually did a thing called a side slip where you actually tip the aircraft to sort of across the airstream as you're coming in to lose altitude because he was too high. And certain systems like speed brakes and whatnot, I think, were inoperative on the aircraft. But he didn't even know whether the aircraft would actually allow him to do that. It was a very dangerous manoeuvre, but they had to do it to land. And they landed safely, and all the passengers got off, and it was an amazing effort. So they're probably very lucky that they had a glider pilot that was able to fly gliders and understood all about that. So we've got an aircraft with a lift to drag of 12, and he has an engine failure at an altitude above sea level of 2,000 meters. Okay, if there's an airport at 500 meters above sea level, 17 kilometers ahead, does the aircraft make the runway? So we need to calculate the descent angle, and once we do that, we can work out the distance that the aircraft will be able to travel. But there's a little bit of a complication because we've referenced sea level, which is the normal way that altitude is normally referenced in an aircraft. They'll normally set to sea level, and then you'll have on your charts what the altitude of the actual aerodrome is, and you'll hear in the I can't remember the term for it, but the announcement that the control towers make, it's on record, a QNH. I can't remember what it's called. Anyway, the QNH is the barometric pressure, basically, at the airport. And you set it to calibrate your altimeter so that it's reading correct altitudes above sea level. So, for this question, first thing we need to do is calculate theta. Okay, now we know that for a small angle, for a jet airliner on a small angle of descent, and we're making that assumption, okay, it's equal to thrust minus drag over weight. Now, because we've had an engine failure, straight away we can get rid of our thrust. So we're just going to say drag over weight, okay? So we also know that that this weight for small angles can be an L as well, okay? So we're going to go minus D over L, okay? So drag over lift. We know the lift drag, so we just have to take our lift drag and find the reciprocal of it. So theta is going to be equal to 1 over 12. So we'll grab our calculator. It's going to give us an angle in radians. And we're going to say 1 divided by 12 and multiply by 57.29. And we're going to get 4.77, so we're going to say 4.8 degrees, approximately. Okay, that's the angle that we're going to use to do our diagram. Okay, so now we need to do our diagram. So we have sea level, we have the aircraft at an altitude above sea level, of 2,000 meters. We have an aerodrome ahead of this situation, which is 500 meters above sea level. And we know that distance is 17 kilometers. This is the airport. Got a little control tower with a radar on top of it. Okay, so we're wondering whether our aircraft, when it's descending at this angle, 4.8 degrees, is going to make that runway, 17 kilometers distance. So we need to use a bit of trigonometry to do that. So the first thing you might want to do is create this triangle. And you know that if these two lines are parallel, that we're going to have alternate angles there. So we know that this angle in the triangle is going to be 4.8 as well degrees. Okay. So that's the first thing you need to do. We know that this is a right angle here. And we know that this distance here is actually going to be 500 less, okay? So we can change this side of the triangle here, from here to here, is 2,000 minus that 500 for the altitude for the airport. So we end up with 1,500 meters, okay? So we've got a triangle that looks like this. 4.8 degrees. And this length here is 1,500 meters. And we're trying to find this distance, okay? Now, if this distance is greater than 17, we know that we have more than enough altitude to make the airport, okay? They'd obviously have to adjust their glide path. But if this number D comes out less than 17, we're going to go into the drink, okay? Because it's right on the coastline. So, we need to find our unknown D. We've got the opposite side, and opposite over adjacent, so Katoa is tan, okay? So we're going to go, I'm going to write up here on the top right hand side of the board, tan of 4.8 degrees is equal to 1,500 over our unknown distance D. Therefore, D is equal to 1,500 divided by tan 4.8. So we get our calculator out. And we go 1,500 divided by tan 4.8. And then we go equals. And we end up with 17.8. And I'm just going to check that again because I'm worried that I may have got that wrong. 1,500 meters. Divided by 8 degrees. Yes, and that's a distance in meters. So we're going to divide by 1,000. And we end up with 17.8 kilometers, okay? So D is 17.8 and we need to go 17 kilometers. So D equals 17.8 Ks. Therefore, we just make it. And that, of course, is assuming that we don't have a headwind, because if we have a headwind, it's going to affect our ground speed and all sorts of weird and wonderful things are going to happen. But assuming all things are ideal, everybody gets to live. Anyway, hope that helps. We'll see you in the next video.